Hi students, today we will discuss thermometry, which is measuring of thermometer, measuring of temperature. Hi students, today we will discuss thermometry. Thermometry, thermo means temperature, so metry means measurement. So first of all you should know, so temperature, what is meant by temperature now? This is the topic which is useful for 9th class students, foundation level, even 11th class topics also. So first of all, temperature. Temperature means what? Temperature. What is meant by temperature now? Temperature is nothing but a degree of hotness or coldness. Degree of hotness or coldness, right? So this thermometer, temperature. So temperature is measured by thermometer, right? So SI unit is what? SI unit is nothing but a Kelvin. So generally we'll have degree Celsius also, we'll have Fahrenheit scale also, we can have, we'll measure it in different scales. So how this thermometer is designed, how is it is used to measure, it is in terms of kelvins or Celsius and Fahrenheit, no? We'll see the principle, no, which is involved in the construction of the thermometer. So let us see thermometer. Thermometer is a device used to measure the temperature. So we'll go for like a clinical thermometer here, no? So thermometer consists of we require like a thermometric liquid, thermometric liquid. Thermometric liquid is what? Here we'll use it as like a mercury. Why this mercury is used as a thermometric liquid? Why? Because this mercury will undergo like a uniform expansion. If the temperature increases, so it is going to expand uniformly. Also, it will not stuck to the walls of a container of a tube, and also it will be like a shiny onto this one, no? Therefore it will be easily able to measure it now. So for this one now, there will be one small porous one tube we are going to take it now, one small tube, no? So therefore, and around this tube, no, there is one more glass tube, it is kept here, no? Now there is a one bulb like this, we can keep it here, no? So here, therefore there is a thermometric liquid is filled in this one now. Thermometric liquid, it will be filled here, right? Now for any scale we require compulsory one starting point and ending point now. So for this one now, the starting point, how we are going to measure the starting point, how we are going to take it as starting point for this one now. So we will keep this bulb of a thermometer in ice cubes, right? We'll keep the bulb of a thermometer in the ice cube. This is your ice cubes. So therefore this ice cubes which is ready to melt now, so therefore then all this thermometric liquid will be comes and settled at this point now. Therefore this it will be taken as like a lower fixed point. Lower fixed point is taken as melting point of ice. Melting point of the ice is taken as like a lower fixed point. So this is one marked now. So in Celsius scale, okay, we'll see. Now next what we will do now, we'll keep this one now, we'll change this as a ice cube, we will remove it now, and we'll keep it as like a one more this hot water now. Therefore hot water bath now. This is nothing but like a boiling water. When temperature of the boiling water is very high, so therefore what will happen now, this liquid will expand here now, and it goes to certain height here now. It will goes to certain height here. Therefore this is a maximum level, no? We can take it as like a UFP, that is called upper fixed point. This is to be taken as like a boiling point of water. Clear? So in Celsius scale, what happened now? This LFP is in Celsius scale. In Celsius scale, what is written now? So in this lower fixed point, melting point of the ice is considered to be like a 0 degree centigrade, and so boiling point of the water is considered to be like a 100 degree centigrade onto this. So this difference is how much now? In this one now there is a 100 difference is there now, 100. This gap which is there no, this gap will be divided into 100 equal divisions now. What we are going to do now? We are going to divide this one into this gap into 100 equal divisions. So what you are going to do now? 100 equal divisions. So when it is this gap is divided into 100 equal divisions, therefore each division, what will happen now? Each division will measures like a 1 degree centigrade, like a 1 degree centigrade. Like that, if you keep this one Celsius thermometer, if you contact with any other body, if it is measured like a 36 degree centigrade, suppose, so this liquid will come to here up to some 36 degree centigrade and it will stops. So by reading that one now, therefore we can understand, therefore that is the 36 degree centigrade as our body temperature. Similarly, in the Fahrenheit scale, what this Fahrenheit scale we did now? Fahrenheit, what he did, he said that 0 degree centigrade is not the melting point of ice, no. 32 degree Fahrenheit is the melting point of our, lower fixed point. And here upper fixed point is taken as like a 212 degree Fahrenheit. So this is in Fahrenheit scale. Now, what is the gap between this one now? The gap between this is nothing but a 180 equal divisions. So this gap between these two, what happened now? It is divided into 180 equal division. That means initially for Celsius scale 100 divisions are there. For this Fahrenheit scale there will be 180 divisions are there now. That means this gap is divided into 180 equal divisions onto this. Like that, so we will measure. See here, which is having more divisions now? Which is having more divisions? Fahrenheit scale is having more divisions, no? So that it will measures more accurately. So more accurately, right? So more accurate. So this Fahrenheit scale will measures more and more accurately. Why? Because its gap is divided into 180 equal divisions, no? So that it will be having more number of divisions, so that it will measures more accurately. Even in Kelvin scale, no? Therefore we can take it as like a 273 Kelvin and 373 Kelvin. This is a Kelvin scale now, right? So this is also divided into 100 equal divisions. Therefore this it will difference of this one, no? Difference in the Celsius scale, difference in the Kelvin scale, it will be the same only. Like that, we can create, you can create any one scale, no? Like a Rankine scale, Römer scale, even you can place your name also, you can create one of your scale, no? Right? So how to have the relation between Celsius, Fahrenheit and Kelvin, no? For all this one, no? So this gap, right? For all this, any type of scales onto this one, no? This will be remains constant. This ratio, that is nothing but a scale minus, so LFP, so by UFP minus LFP, it is always constant for all the scales, right? Similarly, what we can write it now? We can rewrite it as for Celsius scale, right? So for Celsius scale, so C minus LFP is how much now? 0 divided by 100 minus 0. So for Fahrenheit scale, F minus 32 by, so therefore 212 minus 32. Like K minus 273 by 373 minus 273. Therefore you can simplify it, no? You can get it as C by 100, it will be equal to F minus 32 by 180, it will be equal to K minus 273 by 100. This is your relation between Celsius scale, Fahrenheit scale and Kelvin scale. So you can have a conversion from one scale to another scale, like Celsius on this one, you can substitute it, you can get it your answers onto this one, right? So we'll do some more questions onto this one, no? See, therefore any scales, no? Therefore this ratio, any scales, no? Therefore this ratio, it will be constant here, no? So this ratio, it will be always constant. Like this, any thermometer can be designed, so by using this formula onto this, right? So we can have some questions onto this, no? See, simple questions, no? So we know that C by 100, it will be equal to F minus 32 by 180, it will be equal to K minus 273 by 100, right? So now, right? So we can have like a 50 degree centigrade, no? We can convert into degree Fahrenheit and degree Kelvin. No, Kelvins will not have any like a degrees onto this, right? Now 50 degree centigrade, you can write it now, substitute here now, 50 by 100, it will be equal to F minus 32 by 180. How much it will be now? It is 1 by 2, 2, therefore it is 90. So that implies F minus 32 is equals to 90 degree. Therefore F is equals to 90 plus 32. So therefore 122 degree Fahrenheit. Clear? So therefore here you can get it as 122 degree Fahrenheit. So Kelvin scale is how much now? Just add 273 onto this one, no? See, therefore you can write it 100 cancel, no? So C is equals to K minus 273 or K is equals to C plus 273. How much it will be now? Therefore it will be 50 plus 273. So 50 added, no? 3, 7, so 2, 1, 323. So 323 Kelvin, no? So like this you can solve any conversions, no, by using this to this formulas onto this. Clear, right? And also one more question, no, which scale do not have the negative values now? So therefore here Kelvin scale minus 273 degree centigrade, that is nothing but a 0 Kelvin, that is only the lowest temperature, no? Below that there is no other temperature onto this one, no? So that's why Kelvin scale will not have any negative values. Like these questions also you can expect it now. So one more question, no? So we can rewrite it as, so which scale, right, which reading now? Suppose here some x degree centigrade, it will be measuring like a, so therefore x degree Fahrenheit now. Clear? So x degree centigrade, it should be equal to x degree Fahrenheit. So same reading should be there. So what you can write it now? Just simply you can write it now, x by, so 100, so therefore x minus 32 by 180. How much it will be now? This will get cancelled, this is 5, so this is 9. So therefore 9x is equals to 5 times of x minus 32. So taken here now 5x, therefore 9x minus 4x is equals to, therefore minus 5 into 32. This how much now? Sorry, this is not 4x, this is 5x. This 5x no taken here now. 5x means nothing matter, totally 4x is equals to 5 into 32. X is equals to minus 5 into 32 by 4. 4 ones are 4 8s are, right? So therefore 8 5s are 40, minus 40. So therefore you can rewrite it as like a minus 40 degree centigrade will be equal to minus 40 degree Fahrenheit now, right? So this also one of your important question, you can expect it now in the examinations. Clear? So one more thing, so you can rewrite it as here now, so C by, there is a C by 100, it is equals to F minus 32 by 180. How much you will get it now? So this is 5, this is 9. So you can rewrite it as, so C is equals to, so 5 by 9 F minus 32. Clear? So you can write it now. How much it will be? So 5 by 9 F minus, so therefore here it will be 10, 15, 160 by 9. So how it looks like now? It looks like a y is equals to mx minus c. How the graph it will be? The graph you can draw it now, right? So on x-axis Fahrenheit scale is there, on y-axis Celsius scale is there. So therefore here If it is Fahrenheit is 0, so therefore it will be 160 by 9, negative intercept, no, minus 160 by 9, but it will be like a straight line. So straight line, this is a straight line now. So what will be the slope of this one? No, that is theta. So slope what you can write, no, that is nothing but a tan theta. So slope is nothing but a 5 by 9. Clear? So these type of questions also you can expect it in the examination now. Similarly, small thing, small change. Here we will rewrite it as now we know that C by 100 is equals to F minus 32 by 118. 5 and 9 taken here now. F minus 32 is equals to 9 by 5 C, 9 by 5 C. So taken toward this side, F is equals to 9 by 5 C plus 32. So you can rewrite it as Y is equals to mx plus C. If you draw the graph here, no, here x axis, no, so C is there, and y axis Fahrenheit scale is there, no. So if it is C is equals to 0, so 0, so F value will be having 32. Therefore, now here 32 degree Fahrenheit it will be there, it will be a straight line. So what will be the slope of this one? No, slope of this slope, right? So if you draw it, no, so it is tan theta. Also you can write down tan theta or delta F by delta C, that is nothing but a. So what will be the slope? No, therefore it will be 9 by 5. Clear? So like this you can solve the problems related to the thermometry onto this. Clear? One more confusion question, no, it will be there. Now listen, one question, no, see here. There is a, okay, right, change in degree centigrade. We can do this question, no, change in degree centigrade. So how it will be equal to change in Kelvin. So change in Kelvin, change in value. Therefore it will be always equal only. Therefore change in degree centigrade, no, it is always equal to change in Kelvin only. That is what change in degree centigrade, no. Suppose I will take it as like a right here, okay, 10 degree change in Celsius, no, it will be equal to how much it will be now in Kelvins, no, it will be also it will be equal to 10 degree change in Kelvin only. So how it will be? Suppose we will take it as like a 37 degree centigrade minus 27 degree centigrade. Can we write like this? No, it will be like a 10 degree centigrade. So therefore this I can write it as 37 plus 273 Kelvin. So this also I can write, minus, no, 27 plus 273 I will write it now. So 273. So here you can write down 37 plus 273 minus 27 plus, so 27 minus 273. It is in terms of Kelvin. This will cancel, no? This will cancel here, no? So therefore again 37 minus 27 is nothing but a 10 Kelvin, no? So therefore change in degree centigrade and change in Kelvin, no, it will be both are same only. But it is not same for Fahrenheit one, no, let us see. So therefore here 10 degree change in Celsius scale, no, change in Celsius scale. So how much amount of change in Fahrenheit scale will be there, no, we want to write it, no, Fahrenheit scale, change in Fahrenheit scale. So here you can take it as any change, no, therefore 37 degree centigrade, no, you can rewrite it as, so 37 degree centigrade minus 27 degree centigrade. But Fahrenheit scale how much now? So how this reading of the Fahrenheit scale now? So you can rewrite it as, so how much it will be? So C by 100 it will be equal to F minus 32 by 180. Clear? Right? So C1 minus F1, no, and C2 by F1. Therefore C1 minus C2 by 100 it will be equal to, therefore here F1 minus 32 minus F2 minus 32, therefore F1 minus F2 by therefore 180. This is the change in Celsius by change in Fahrenheit onto this. Therefore, here you can write on change in, so Celsius by 100, so it will be equal to change in Fahrenheit by 180. So what you can write it now? Therefore, change in Fahrenheit, so we can write it as, so 180 divided by 100, so change in Celsius. How much it will be? So it is 9 by 5. So 9 by 5 change in degree centigrade. So 9 by 5 into 10 is how much? No, 10. So degree centigrade, no. Therefore here, right? So how much it will be now? 5 ones are 5 twos are. Therefore 18 degree Fahrenheit now. Therefore change in 10 degree Celsius no will be always equal to 18 degree Fahrenheit. Therefore, so these things therefore keep in mind. So about the change in the value, right? So this is one confusion question, no? Right. One more question, no? Suppose a student, what he did now, what this student he did now is to, this is used one faulty thermometer. Faulty thermometer. What is the faulty thermometer? Therefore, LFP is noted as minus 10 degrees centigrade, no? So UFP is mentioned at 90 degree centigrade now. Clear? So 90 degree centigrade. So if this faulty thermometer is reading about 40 degree centigrade, what will be, 40 degree due to the faulty thermometer, no? 40. So what will be the real, correct temperature in Celsius and Fahrenheit? Like that also they can ask. So any time, okay, clearly mentioned now, this is a faulty thermometer. What you have to write it now? Always scale minus LFP by UFP minus LFP. This should be constant. This formula only we have to use it for all the thermometers, right? Now scale. So for faulty thermometer, no, faulty thermometer reading is how much? No, suppose some f small f, no. Therefore it is 40 minus LFP of this one is how much? No, minus 10 degrees centigrade. So UFP is how much? No, 90 minus of 10 degrees centigrade. He is asking in Celsius. Current Celsius means C by 100. Clear? So C minus 0, 100 minus 0, like this. Okay. So then what you can write it now? Here it is 50 by 100. It will be equal to C by 100. Therefore it can cancel. So C correct reading it will be equal to 50 degree centigrade. Even they may ask you what will be the correct Fahrenheit scale. Instead of the Celsius scale, no, you write down Fahrenheit scale there. So they may ask you any other different things onto this, right? So this is one of the basic concepts for it will be useful for foundation level, 9th class foundation level, no. So also NEET level also. Okay. So next part we'll discuss regarding the heat and calorimetry onto this. Okay, students. Thank you for watching. So please subscribe to my channel now.